is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hey, hi there, everybody.
Hey.
Welcome. I had a screen that was blocking me just a moment ago, so it's back.
Hey.
Hi, everybody. And guess who? It's Tara. Hi, Tara.
Hi, how you doing? Hi,
I'm just fine.
everyone.
Welcome to Sky to Radio tonight here on this
Yeah.
wonderful, well, gosh, it's March 26th now.
Wow.
And it's a good thing. I had a presentation tonight to do at a local vineyard, the best vineyard in Connecticut.
Nice.
And they moved it to May because of a scheduling thing. So that's even better. So that means I can do another. Look at this. We got this. The ship is rocking here.
Oh,
It means, I know. It means now we get a chance to do another live Sky Tour Radio, which is what we're doing. Sky Tour Radio is your ticket to the astronomical world. I'm an astronomer. That's what I went to school for. This is what we look like, you know. And Tara, yeah, you're wondering, Tara over there, okay, she's an artist, but she's a darn good one. And you've seen her work. I've shown it to you many times with the door of our Sky Tour live stream observatory in the Sonoran Desert, west of Phoenix. And we have this new observatory, Tara. I was kind of suggesting that maybe, and we just got a new door put on, and it's just plain old white.
Oh, let's nail the old door to that door.
We're not losing that other observatory. We have two.
Oh,
now.
That's right. You can't do that.
Yes, not yet. If at some point we move it, yes. That's a beautiful, clean white door.
Yeah, I have plenty of bottle caps. I'm sure I have plenty to go over it.
I'm sure you do. It's kind of interesting, when she spent time building that door for Sky Tour live stream 1, which is the Sonoran telescope. The door was beautiful, stunning colors, and she recreated the Orion Nebula, right, which is just beautiful.
Right.
Yeah. And then over time, it faded, and it went from looking like a beautiful color photograph to a black and white photograph, or even a sepia photograph.
Yeah,
And it's
I'd
kind
say
of cool.
sepia. Yeah, rusty sort of.
Yeah, but it's cool though. I mean, it has a character all its own. And I wouldn't trade it for the world. It's really beautiful. So that said, I wanted to mention to you that now that we have our second observatory open, it's on the Benson Plateau. There's a plateau out there about 3,600 feet in altitude, and we're sharing the mountaintop, if you will, with other astronomers. Here is the line of observatories on the mountain, and this is ours.
Oh, yay!
Okay, yay, yeah. Oh, look, we're kind of split right there. That's kind of cool. And sadly, we do have some issues with the internet, but it's actually doing okay. And we are a 501c3. We do need some additional equipment for the building. We want to get a what's called a field rotator, because our camera's plastered on the end of the telescope. Okay. Right. And if I show you this picture, okay, you can see right there, okay, at the end, that red thing on the very end, that's the camera. Yeah. And just ahead of it is that black thing. That black thing is a filter wheel that has filters in it. And that entire assembly, or just ahead of that, we would have this field rotator. Now, what does that do? What it does is it rotates the entire assemblage of camera and filter wheel to help us better place the image that we want to guide on with our guiding system, which you can't really see. It's on the other side of all that right now. Right, we're directly on the opposite side of the telescope from it. So what it means is that when we have, this is a better view, you can actually see that thing sticking up there. That's the camera, and the that thing right there.
Oh, right
Okay,
there,
is
right
that black
there.
thing
Oh, wait,
behind the red
there. Oh, the
box.
other way.
There's a red box
Got it.
there. There's a red box up there. Yeah. Yeah, we can't like put our cursors over this. I can't show you.
No,
But the bottom line is that
cool.
the field rotator, I think it's like a $400 item. And as soon as they get them, they're already spoken for. So we haven't bought ours yet, but we want to. And as a 501c3 nonprofit, I have applied for a grant to help us, do a better job of bringing astronomy to you. And one of the additional pieces of equipment I want to add is a spectrograph, which will allow
Ooh,
us. You know what that'll allow us to do?
nope.
When we look at a nebula, okay, and we have several. Like here's one. Okay, this is the Crab Nebula. This is an old supernova that occurred, um, oh gosh, in 1054 AD. The Chinese saw it as a new
I
star in the night sky.
Yeah, they documented it, I think.
That is right. You're absolutely right.
I
They did.
remember that.
And now, if we look at this with our telescope, this is what we see. I took this actually 2 nights ago, right,
Pretty.
out in Benson. Yeah, it is. But you say pretty, and the reason you say is because it has pretty colors,
Mm-hmm.
right? But the colors mean something. And from experience as an astronomer, I can tell you that the red is very likely hydrogen, okay, and that the bluish green is very likely oxygen. But what about the whitish, and what about the other colors that are also present in there?
Yeah.
Well, we can only make a guess, Tara, right? That's what we have to make a guess as visual observers right now, looking at the picture. But if I
Mm-hmm.
took a spectrograph and I pointed it at this, I would not only be able to identify those elements I just mentioned, but all the elements that we're seeing, because stars are element factories. And when they exploded in a supernova, they release them all. They release their guts to the universe. And it spreads out because nothing's going to stop it. And it eventually permeates the entire galactic region where they go off, because these are all within our galaxy. And
Mm-hmm.
then those elements are then free to be used to build new stars and planets, right? So the bottom line is that a spectrograph will allow us to see all those elements that were created in this supernova explosion immediately. We don't have to wait. We don't have to take a picture. We can just look at it, and it will show us what elements are in there. This
That is,
is it is the next phase of what we
yeah.
want to do, right?
I have a question for you, if I may. So those
Yeah, always.
colors you were just showing that picture, you're saying that, obviously the red is this and that, but those colors like the white, the spectrograph you're saying that will show us what that white is, or it's just going to show us a black band. But if determine me just further, if we see the black band and say we know it's some element that is green, do we assign that green color to that picture that you just took, or
No, that's the nice part. Okay, first of all, the colors that we see in this object here,
right?
okay, this is light being given off by that nebula. Okay, so
Okay,
this isn't going to show up as a dark line in the spectrum. Like last week we talked about these dark lines here you see, which
right.
show up in different stars, and they also show up, because of the fact that, and I made this, I think I might have mentioned this. It's when you have a hot source like that blue thing right here,
Right.
okay, and that hot source is relaying radiation through a much cooler gas, which you see to the right. That much cooler gas is what's around the core of the star, right? Because only the core of the star is doing the fusion. That's the hottest place in the star. All the rest of that big ball you see in the sky for the sun, all right, all the rest of that is just along for the ride. But it's plasma. Yes, it's thousands of degrees, but the core is millions of degrees. This thing right here is millions of degrees in that central spot. So that gas, even though it's thousands of degrees that this light is going through, this radiation is going through, it's much, much cooler than the core. And what it does is it absorbs some of the energy going through it from that radiation. And that upper one up there that you see, that one there shows what's called a continuous spectrum, just the rainbow of colors. This is what you would see if you didn't have a starlight going through a gas, like the outside gas around the star,
Mm.
you would just see a continuous spectrum. However, if it's going through the gas, you get these dark lines that you see in this center one all the way on the right. And that's because the gas is absorbing some of the energy coming from the center of the star. So they're called absorption lines. However, the gas, like the gas we see for this nebula here called the Crab Nebula,
Mhm.
this stuff is actually emitting light. So these are called emission lines, and these show up as we saw in this image here. Okay, like at the bottom here, like down here at the bottom, you can see at the bottom there it says emission spectrum. If you're
Mhm.
just looking at the gas, let's pull the gas away from the star and let's make it the Crab Nebula, the nebula we're just looking at. Well, the gas coming out of there is ionized gas. It's excited by the ultraviolet energy coming from the stellar remnant at the middle of this nebula. And so it's going to emit light. So you see it as red for hydrogen. You see it as greenish blue for oxygen. You see other colors and you see other elements in the star's spectrum. Because as I
Mhm.
said, stars are element factories. And these element factories can be seen using the magical spectrum of the stars. And the magical spectra is to me, that is the thing that actually is the most educational about astronomy. Because all we have is the light, don't we? Coming from the sky.
Well,
All we've
yeah.
got is the light,
Mhm.
right? So it's up to us to figure out clever ways
Well,
to see it.
aren't there gravitational waves? Aren't there other things that might be out there that?
Good point. Okay, when we talk about light, light comes into us as waves, right?
Right.
And light has both a particle nature and a wave nature. We can talk about a
Mm.
photon of light, right? Little packet of light. And we can talk about a wave of light.
Okay.
Okay. That's called duality, and light does that. Okay. At the atomic level, atoms do that too. They can be described with equations, all right, and or as particles. We can talk about an
Mm.
electron, but we can also talk about a probability distribution. And we can put an equation up which talks about where the electron might be in the atom at any one time. It's a little crazy to think about, okay? But that's the dual nature of most things we understand in the
Mm.
universe. Now, I say most things because with gravity, we understand, as you just pointed out, we understand that we can see waves of gravity now, something Einstein never thought we'd be able to see.
Right.
But we see
Oh,
waves of
cool.
gravity, obviously known as gravity waves, and these come from, say, two black holes colliding. They send ripples through space, like ripples on a pond when you throw a rock in. Okay. And those ripples go through the medium that is space. And I know you think of space as being empty. Um, it's actually not empty mathematically. Okay. It has what we call a fabric. In other words, gravitational force can affect space. So we have to say, well, what term do we use to describe what's being affected by gravity? And they're like, I don't know, Frank, what do you want to call it? A medium? I don't know. How about a fabric of the universe? Or, hey, that's it, a fabric of space. Okay, we'll call it the fabric of space. So calling it fabric is a metaphor, and it's also kind of an instructional, intuitive thing to think about for how gravity might work on space. So when we
Mm.
talk about like black holes, when they collide and they send out these ripples, okay,
Mhm.
we're also thinking that stars do the same thing. Stars actually, when you have a star in space, it makes this gravitational well. Think of a
Yeah.
rubber sheet stretched at all four corners, and then you put a big, heavy bowling ball in the middle. It's going to go down, it's going to sink down in, right? That is the expression of gravity, okay? That deep well. And you can imagine that if you send something around it, it'll circle around it. And as long as it's getting a little kick every now and then, or it's falling as fast as it's moving forward as it's going around, it'll stay in a circular path. But take away some of its energy and it's going to start spiraling in toward the center. And we've
Uh-oh.
seen this with marbles on a slanted table. They go and fall through, right?
Yep.
Well, that's because they spiral in. And we notice planets do that too. Planets spiral in to their star because something is causing them to slow down. Usually, it's emission from a star, clouds of dust and gas being thrown off by the star. There's dust made in the outer atmosphere of these old stars, and that dust can go out into space, and it impedes the motion of a planet by a very, very, very little bit.
Enough.
Just enough. Exactly. Just enough to cause the planet to slow down a little bit and thus get closer to the star each time. And then finally, whoop, it goes in and gets swallowed up by, say, the star. Okay. Well, black holes that orbit each other also have a tremendous difficulty staying in a perfect orbit with each other because they're giving off all kinds of radiation and they're impeding each other. So eventually they're going to spiral into each other. And when they collide, that's what that ripple is that we see in space. And that fabric I've been talking about of space gets bent. Okay.
Does it bend or start flapping in the wind like a sheet?
That's a very good point. It actually bends. So, for instance, if we have a very big gravitational thing, right? Let's say this is a cluster of galaxies, and we have something back here that we're looking for, something like a light object, some object, maybe a single galaxy far away in another cluster. As the light approaches this galaxy, it gets bent toward this galaxy's cluster, and it gets bent in all directions. So if it's back here, okay, it'll get bent around this way, get bent around that way, around this way, around that way, and we'll see what looks like a ring of light around the distant galactic cluster. That ring of light is that distant galaxy's light that's been ripped apart and moved because of gravity. Now, the thing is, light has no mass, and mass is the thing that is affected by gravity. So wait, how could light be moved then?
Yeah.
How come they say in a black hole, the gravity is so strong that not even light can escape it? That means that sounds like, and incorrectly, that light is held back by gravity and can't escape because it's trying to get out, but gravity pulls it back in. That's what it sounds like, but that's not what it is. Okay, what's actually going on, this is a tangent, I know, but it's a good one. What's actually going on is these black holes are warping space, and near the black hole, that warp gets so steep. Remember that indent I was talking about with the bowling ball? Okay, it gets so steep that when light starts circling at a certain point, it might be able to go around up here, but as soon as it enters, there's a point where it can't anymore get out. And so it's going to keep going. Why? Because light follows the curvature of space.
So is there a lip on that curvature of space at all on that black hole? Because it seems like...
Well, the entrance point, okay, first of all, it's three-dimensional.
The event horizon there, is that?
Yes, the event horizon is the place beyond which the light, once it enters, the curvature is so steep and light's constrained to follow the curve, okay, that it just stays in there forever. Okay. If you think about light as an object that has no mass, that's weird to think about because we don't even know how to visualize that. But light is a car moving on a road that has hills. Okay. The hills are the universe, and gravity affects the shape of the hills. Gravity makes the hills. Okay. It makes hills. It makes depressions. It makes other things. So the car has to follow the curvature of the hill. And of the hills. This is kind of cool. Look at that. All right. It's Hawaiian. Okay. You're the one that's been to Hawaii. I haven't been. Okay. So when you look at the light following that, or the car following that curvature, what we're really saying is that light also follows the curvature of space. Light is constrained to go in a straight line as far as it knows, from the point it leaves its source to the point it ends. Okay. It goes in a straight line. As far as it's concerned, what's really going on is that it's following the curvature of space. So whichever way space is curved, it's going to go. And so that's what black holes do. They curve space. So even though light has no mass, light is constrained to follow the curvature of space. So therefore it does. And that's the thing that is the reason, in fact, that we have um, uh, gravitational micro lenses, which are the galaxy images showing up in the foreground when now the galaxy cluster is in the foreground. The light going around is being bent by the gravity of this big giant cluster.
Isn't that how they proved Einstein's theory? Was the light bending behind? That was a full moon, though, or
no, that was a solar eclipse.
Solar eclipse, but
yes,
it's the same concept, though, right? And
that's correct. That's actually one of the classic proofs, was to show that light followed the curvature of space. Now, we understand gravity to act on things that have mass. Okay, this water glass has mass. If I drop it, it's going to fall because gravity is going to pull it down. Right? I won't do it. Okay, because all of a sudden, be gone. Okay, but it's like, sorry, I'll be back. No, but the fact is that gravity acts on things that have mass, like you, like me. Okay, but that gravity, we're used to acting on mass, objects with mass. We're not used to thinking about how gravity affects things like light, because light has no mass. Light is a quote unquote massless quantity. All right. It's an odd way to think. I mean, it has something called relativistic mass related to its momentum, the speed it's traveling with, the velocity it's traveling, which is the speed of light. Okay. But that said, the thing that's important here is to understand that it's space that's warping and light's constrained to follow space. So now you can understand why light, which has no mass, is affected by things with fantastically high mass, because they're bending space and light follows the curvatures created by those giant things. Okay. So there you go. That's the basic concept. And so when gravity is upset by the collision of two big black holes, well, space is bent a lot, and those ripples travel outward, and they propagate through space. We see them, and we have detectors on the Earth. There's three. There's one called Virgo in Italy. There's one in Louisiana called LIGO, L-I-G-O, and one in Hanford, Washington called LIGO. LIGO stands for Laser Interferometric Gravitational Wave Observatory. That won't be in the test.
Good.
Yeah. Yeah. But the point is, these LIGO detectors detected these ripples coming through the Earth, and they hit Washington, Louisiana, and Italy at different times. And from those, we could deduce where it was coming from and how fast it was moving and what it was.
Cool.
And it was incredible to actually see that gravity has waves. Now, the one thing and so now Einstein was probably rolling over in his grave, as they say, because he's like, I did not think we'd see these things. Okay, it's true, and he didn't think so. But the other thing that's important is that this means that if we see gravitational waves, what's next? We have light waves, we have light particles, we have electrons being both a wave, effectively, or a particle. What about gravity?
Is it a particle?
Wave, and where's the particle? Exactly. We have to look for the graviton. We can't see the graviton, and the graviton, yes, the graviton could be the key to interstellar travel. Okay, I've talked about it's one of my most popular lectures I give in the country, and it has to do with the way we can potentially generate these gravitons, which would allow us to travel interstellar. That's a different show, different lecture, a different talk. But all that said is it goes to when we look at the concept of gravity, we look at it and say, hey, it's warping space. It occurs as a wave. Maybe it occurs as a particle too, and we just haven't found it yet. And I think the reason we haven't found it yet, Tara, is because it's not in our 4 dimensions. Yeah. Light starts and stops here. Wait, is it? Light starts and stops here.
You're implying that it goes past dimensions, then that you don't. It
I'm
could.
actually, yeah, I'm thinking, and I'm not the only one that thinks this. There's
Huh.
there's astrophysicists that have Avi Loeb, for example, at Harvard. He just came on board with this concept.
Wow.
I've been talking about it for like 4 years, and
Yeah.
he just said, I think that aliens travel interdimensionally. You know,
And so you think it's the graviton that's maybe allowing that,
yes,
perhaps?
exactly. Okay,
Huh.
now that process.
Interesting.
Okay, yeah, it's a very interesting process.
Hmm.
I know that we did a show on this before, um, and yes, almost correct there, Genghis. Thank you. LIGO, Interferometric Gravitational Wave Observatory. Yep. So um, when we talk about gravity as a fundamental force in the universe, it's actually the
Mhm.
weakest force there is. It's not
So
very
weird.
strong. Yeah.
Mm.
And you say, but wait, Pluto is orbiting the sun and it's billions of miles away. Correct. But gravity's the weakest force. So what's that tell you about the other forces?
They're
They
strong,
gotta be monstrous. That's correct.
stronger than
Yeah.
dirt. Yep.
Yeah. Well, the
Mm.
strong force, which is one of those quantum forces, the ones at the atomic level,
Yeah.
uh, interesting. Those hold atomic nuclei together. Now you say, well, what's that all about? Well, okay. Have you ever taken two magnets and taken the two north poles and try to push them together and it's just like, it just can't do it, right?
They can't do it, huh?
Yeah, very powerful magnets here, and you try to do it, it's like, and it just doesn't do it. You cannot make them touch. Okay. In fact, here you can make them go right like this. That's fine. That's fine. But as you get closer and closer and closer, it gets harder and harder and harder until it's literally almost totally impossible to connect them together and cause them to press together. Okay. You could do it under great force and pressure.
Right.
Okay. So that great force at the atomic world, at the atomic level, is the strong
Strong
force.
force.
Very nice name, strong force. Good thing we didn't call it the weak force, but that also exists. But the strong force holds the atomic nucleus together. Now, that makes a lot of sense because you have to consider that even though like hydrogen is one proton and one electron in a cloud around the nucleus, okay, what about oxygen? Okay, oxygen has a lot of protons, relatively speaking, right? In
Mhm.
its nucleus. And, uranium has many more, right? Over 230 of them. Again, depends on the isotope, right? How are all those protons being pressed together? They're being pressed together by the strong force. And it goes even deeper than that. It goes even deeper than that. It goes all the way to something called quarks and how protons are made. And there's something called a residual force, which again, another time, another talk. But the bottom line is that this strong force can hold this nucleus together. But after about 118 protons, okay, all right, that are in,
Specifically.
yeah, yeah. And when I said 232 for uranium, I didn't mean 232 protons. That's don't mistake that. Okay, but if you talk about say 118 elements, right, that we have at 118, that's about the maximum number of protons you can have. When you go to 119 temporarily, whoop, they just pop off and they just come back to 118. They decay, right? And when they decay, then that decay is something that is the reason why we're here. Okay,
Mhm.
because and that has to do with the weak force. All right, and something called beta decay. There's beta minus and beta positive, beta plus. Beta minus decay, though, is the one that is responsible for us having more elements in our periodic table from the cores of stars. The other one works too in supernova and so forth. But I want to mention that when we talk about beta minus decay, what does that mean? It means that we have a proton. Let's say we have an atom that has two protons in it.
Okay.
All right.
Yeah,
So
let me
not one like
these.
hydrogen, but the next one in the periodic table has two because we
Mhm.
count up by one. And
Okay.
what is that next element in the periodic table after hydrogen? All at once, class. Helium, right? Okay. So
There
helium is,
was a test. Darn
I
it.
know, I lied. Okay. So helium has two electrons, two protons in its core and two electrons in the outside shell. Okay. Well, sometimes you can get a neutron which has no charge. That's why neutron, as a neutral, has no charge,
Mm.
but it has mass, and it goes into the atom and can join the nucleus. And now you have a special variation of that atom called an isotope. So whenever you add neutrons to a regular atom that has its set number of protons, like we see in the periodic table, you add more neutrons, that's an isotope. Okay. I used to say that it's like a different flavor of the same atom, but flavor is actually a characteristic in the quantum world, so I'm not saying that anymore. Okay. But think about this. Those neutrons now that are inside the atom, you can say you get an additional neutron or even two. Sometimes one of those neutrons can spontaneously decay and become a proton.
Okay.
Yes. So now you'll have an atom that has 3 protons in the nucleus and not 2. No? Yeah, looks like I see that alien over there. They're talking. That's right. Dear God, it's an alien. Oh,
Oh my.
Give me Jaws any day. Okay. So, the nature of these elements then is such that they build up in a star over time, using a process called the slow process, and it's called neutron capture. It's a slow process, and a neutron gets converted somewhat randomly to a proton, and now you have a new element. Okay.
Cool.
Yeah, and it just goes on, and so many times that'll happen. So stars like the sun do this. Okay, stars like Betelgeuse, on the other hand, they do things a little differently. Okay, Betelgeuse is a very massive star. In fact, when we talk about the stars and the types of the stars there were, you might remember we talked about the different temperatures of stars. Okay, and the hottest stars that we see are the stars that are in the upper left of this diagram.
Oh, yeah.
Right up there, those O stars, those are hottest and bluest. Down there at the bottom, those are the coolest and the reddest. And those coolest and reddest stars are the ones that may very well have the key to the most life in the universe. But that's just another point altogether. But those hot blue stars, that's what Betelgeuse was when it first formed. It was one of those guys, right? Well, now it's over there above your head in the supergiant. You see it up there? It's in the upper right. It even says Betelgeuse. Yeah. There you go.
It's hard to point backwards.
You get good at it after a while. You're like a weatherman. And here's the front moving in.
Yes.
Yeah, so Betelgeuse was a massive blue star. But wait, Mark, it's red. Yes, because what happened was after Betelgeuse ran out of its hydrogen that was fusing into helium, okay, it began to, the core now began to shrink because its own gravity was causing it to get smaller because it didn't have enough outward energy to hold it up. So it started to shrink. And when that happens, it gets very hot and starts to expel a lot more energy, and it bloats the star and pushes those outer layers off. And we get that we see in the upper right-hand corner there. We get a super giant, a red supergiant star, which is what we see with Betelgeuse. So meanwhile, the core of that star is still furiously fusing, but it's no longer fusing hydrogen into helium. It's fusing carbon into nitrogen isotopes and oxygen, okay? And then it's moving on and getting possibly to iron. And at iron, we can't fuse anymore. Now, the reason is because, and I have to show you the diagram, which I don't have, but you can take my word for it. You can look this up. When you have to trust me on this one. But when you have a star like Betelgeuse, it gets to iron, and that's in the core. And of course, they're all ionized atoms in there. So there's only nuclei. There's no atoms with electrons running around. Okay, the electrons are all free in this plasma region. And so when we have iron in the middle of that star, all right, if you can imagine, how can you fuse iron into the next element, further on down? Well, you can't, all right, because the problem is, to do that, you need to put in more energy than you get back. And that's like saying, I can't climb the stairs anymore, okay, because I simply have run out of energy. So if you're out of energy, you can't do that next step up the stairs. So therefore, iron is the last thing that stars can make under these types of conditions where they exist normally. Now go into a supernova stage where Now that iron is basically now this solid segment in the center of the star, and now all these outer shells around the core are fusing and making different elements. Okay, as this example shows, you have this inner iron nickel core, as you see there. Then you have these shells on the outside. You have a hydrogen burning shell, then helium, and then carbon, neon, oxygen, and then silicon. Now that silicon burning shell is that next one right outside the core. That's to do that, to burn and fuse silicon, all right, and make silicon, okay, fuse into something else. You have to have such incredible temperatures. And so when you look at what happens next, well, every one of these shells, these different colored loops here, you see the rings, every one of those shells is going to run out of fuel. Okay. And when they do, there's a problem, because the star will suddenly collapse. There's nothing holding it up anymore. The outward flow of energy is what's holding it up. It's a big tenuous ball of gas. Kind of, sometimes they bounce back and forth. They kind of change their size and they change their brightness due to this fluctuation. And these fluctuations are well known in some of these red giant stars. And so when we look at this, we say, wow, if that is going to happen, and we're going to get this fluctuation, and then it all goes and shuts down, well, now there's no energy going out, and you got all this mass. And mass likes to contract, right? When in the presence of gravity, it just contracts and contracts and contracts. And if it's actually yes, it's fusing its carbon as well as some additional elements there, Sam. If it continues to contract, then of course it's going to get hotter and hotter and hotter. And then what happens in the final stages is that the star's core simply is now inert. It's not doing anything anymore. You got that iron nickel in the middle, and all these other layers are crashing down from all sides on it, and it doesn't go anywhere. So what happens is they call it a rebound, and it hits that core, it bounces off. All right. And as it bounces off, there's material that reached the core first coming out, while other material is still falling in, and they're ripping past each other. Okay. During that process, they give off these particles called neutrinos.
Ooh, I've heard of those. Yeah.
Yeah.
Aren't those dangerous?
Well, there's billions of them going through you right now as we're talking. So it can't be that bad right now. But streams of neutrinos, we have neutrino detectors. They're very, very hard to see. But there are neutrinos coming to us, and the first thing that leaves the star when it's finally decided to go supernova is this neutrino pulse. And so Betelgeuse will look the same to us. We'll see it in the sky. It'll be red in the sky, a red supergiant, but we might get a burst of neutrinos from it. Trust me, they're watching Betelgeuse right now.
And that's in the middle of the earth. Aren't they deep underground looking for those neutrinos?
Correct. They're down deep in the ocean, deep in the underground, deep in the caverns. And so, and they have an ocean of basically water in there, and that to help the detectors. And so when the neutrinos come and reach the earth, that means that the supernova visual explosion is probably an hour or two behind it. Because yes, it's a preview. It's a preview to coming attractions. So what happens is, as those neutrinos are fighting their way out of the star, and 1 in 1 billion makes it out of the star. How about that? All the rest are absorbed and hit other things, but one of them gets out. And there's so many of them that we see a stream of billions of them, okay, that get out overall. So in other words, the scales are simply unimaginable. And so, yeah.
They can tell where they're coming from?
Yes, because the neutrino detector will be able to detect where they're coming from and at what time this detector reached them before this detector did, or this detector. And they can basically use that as a pinpoint to kind of show where they are looking in the sky. And there's multiple neutrino detectors. So multiples can triangulate an area. And that's how we'll know when Betelgeuse is actually in the process of going supernova. Can you imagine that?
Oh,
So,
I want to see it.
well, no, because all telescopes will train on Betelgeuse. And even if it's in the daytime, they're going to train on the location where Betelgeuse is. And the reason is because when Betelgeuse goes supernova, we're going to see it in our daytime sky like another sun. Not as bright, tiny, okay? But it's going to be a very bright second star in the sky for a period of a few weeks to a couple of months.
Wow. Do we have to
Yeah.
look at it through like we do eclipses, or can we?
No, that'll
Okay.
just, yeah, that's too far away. The intensity of light falls off as the square of the distance, and Betelgeuse being 750 light years away, not going to be dangerous to your eyes. Okay.
Great.
Yeah.
Awesome.
Yeah. So I really want to see it. I want it to happen.
We'll have time to make popcorn.
I want to see Betelgeuse blow. Yeah, in fact, you will. You'll be able to organize a party and have your friends show up and say,
Yep.
we're going to go watch Betelgeuse explode. What time? Oh, in about 22 minutes.
Oh,
Okay, I got my chair. All of a sudden, there it goes.
that'd
Gotta
be
love it.
amazing. Oh yeah, you
Yeah.
gotta love that.
And so when you look at in other words, the point being, the reason why there's a difference in time is because neutrinos are light. Okay, light energy. It moves at the speed of light. Okay. However, the explosion is physical matter. It's protons and electrons, which are actual matter. Okay. So they can't go the speed of light. So they're going to go a lot slower relative to light. And so they're going to take several hours to get out of the interior of the star. And when it breaches that surface, the photosphere, the outer area of the star that we see, in the sky or at the sun, when we look at the disk of the sun in a smoky sky, when it breaches that layer, the star is going to be obliterating itself.
Wow.
And it's just going to go, and you won't see it, but it's going to get bigger and bigger and bigger in the sky, and it's going to cover up everything.
Ah!
Okay. And what's interesting about that is that in a fairly reasonable amount of time, we'll see something like this. This is the Crab Nebula, a supernova. The exact process I just outlined happened here. Okay. This was seen in the night sky in the daytime as well. All right. So this means that this object that blew up, and it's thousands of light years away, was very visible to us. And Betelgeuse is hundreds of light years. So it's a lot closer. So Betelgeuse stands a chance to be very bright in our nighttime or daytime sky, depending on where we see it. Either way, we're not going to miss it.
Oh, it's going to be exciting.
Isn't that something?
Yes.
Isn't that something?
Something.
Yeah.
Well, cool. So we plan to get pictures of that. Do we have photographs? This is a stupid question, of other supernovas? I mean, as they went off, not after the fact.
Oh, very, very good point. Okay. As we just pointed out, this was one after it went off.
Right.
Did we seen any before or during? Yeah, we kind of been close. There was one called Supernova 1987A.
Oh.
And Supernova 1987A, when it went off in our galaxy, okay, some supernovas are in other galaxies, but when this one went off, they saw the explosion, trained the telescopes on it, and they literally, because it was in a cloud of dust and gas, okay, dust mostly, they literally saw the expanding shell of light as it left the star blowing up. And those are called light echoes. They saw the echoes of the light off the dust as it was moving through.
Oh, cool.
And that is cool. Yeah, very, very cool. And that's something that under the right conditions we could see.
And we could photograph through our observatories.
Yes, we can. Yes, we can.
Very cool.
And if we can get that spectrograph and we look at the Betelgeuse, we could tell what elements Betelgeuse was made with and had in its outer envelope when it blew up.
Right.
They'll all be there. So very cool stuff. See, I mean, I got Einstein's hair, so I might as well talk like him, right? I guess. I get a haircut and I'll be like, hi. Hi.
Isn't that,
little drool.
With that Samson who's got his hair cut off. Maybe I'm wrong with that. So
something like that. I remember that story. Yeah. So I realized, like I said, that what I mentioned in the description of the show is not exactly what I'm talking about now. But we're going to talk about that soon enough. We're going to get to that. But this was a precursor and a preview. I also wanted to share.
Mhm.
Now I showed you this picture. This is the one we took. I took that 2 nights ago, but I took this one the same night.
Ooh,
Look
I
at
know what
that.
that is.
Isn't that
That's
beautiful?
part of Orion, isn't it?
It is indeed.
Mhm.
You'd recognize it.
Yep.
Okay. This is actually the top part of the Orion Nebula. The Orion Nebula would go off the page to the top. And I'm focusing on this one area. It's called Desmourins, Desmourins Nebula, or Messier 43. Now, the Orion Nebula is designated as Messier 42. Now, what's interesting is we talk about these supergiants. We talk about supernovae and what happens when they go supernovae. Well, you're looking at stuff that littered the cosmos because of those supernovae. Okay. This stuff we're looking at right here, all right, you'll notice some of it's sort of a brownish dust, reddish dust. That's dust, in
Mhm.
fact. And you can see the hydrogen areas that are sort of pinkish orange, all right, are glowing. That's ionized hydrogen. When you ionize hydrogen, in other words, you send in energy to a hydrogen atom, the electron gets kicked off the atom and it becomes just a hydrogen nucleus. And when the electron comes back into the atom, because it ultimately will, as it drops back into the atom, it gives off energy and it gives it off in the form of light.
Mm.
And for hydrogen, the predominant, they're called transitions, the predominant transition in hydrogen is hydrogen alpha, which is the reddish pinkish light we see of a nebula when we
Pretty.
look at it. Yeah. But the brown dust, on the other hand, this is the stuff that was made in the outer atmospheres of stars like Betelgeuse. All right.
Mhm.
Large stars. And then when they went supernovae, they littered the cosmos with this dark dust. Now, in these outer atmospheres, the temperature is very low. That's why the stars are red. Blues, remember, are hot. And thank you, Isabella. Blue is hottest, and thank you, Kurt. Blues are hottest in the universe, and reds are the coolest. Um, and I think that we have to consider that Betelgeuse being cool like that in that far, far reaches. If you put Betelgeuse where the sun is, its outer envelope would be out as far as Jupiter's orbit. And as we know, it's very cold in
Wow.
Jupiter's orbit. It's a
Mhm.
big, big, big star. And it's a tenuous star. It's like you could possibly fly through the outer layers of Betelgeuse, and you might see the core of Betelgeuse when you got closer, but you might not even notice you're flying through part of the outer atmosphere of Betelgeuse
Mm.
because it's so tenuous. But in that region that's still hot, but not hot enough to separate atoms into their constituent particles like protons and electrons, you might actually get not just atoms, but molecules. You
Ooh.
might get molecules of carbon attached to each other.
Okay.
You might get
Um,
carbon and silicon attached to each other, and silicon to silicon, carbon to other compounds. And then out in that dust, like we're seeing here in this image, that's very cold. In the middle of that dust, it's very cold, and temperatures approaching absolute zero. All right. So when we have temperatures that cold, any other things that were made in the stars that are also floating around in those dark dust clouds could potentially form some type of an ice. And we
mhm.
might have molecules out there of water that would form ice that could settle into and land on one of these dust grains out there. And so we have water frozen onto the ice. Carbon monoxide gas can be, part of this mix and trapped in the ice. We can have, other, yes, Kelvin temperatures, Karen. Kelvin's a temperature scale that starts at 0 and goes up, right? So, like in Fahrenheit, it's like minus 459 or so degrees Fahrenheit and minus 279 degrees Celsius for absolute zero. But we just wanted a scale that could start at 0. So these dark clouds are not going to be quite absolute zero. They might be, minus 175 Celsius, You know, but that's still warm enough or cold enough to allow ices to form on the dust, and they'll just coat the dust. And what this really is, these are the building blocks of life that are being trapped in this dust until such time as a star comes along that might actually be not too hot, not too cold, to allow the formation of planets around it through this dust, which has lots and lots of different elements in it. And thus, we also have lots of hydrogen in there, which is responsible for that reddish part of the light you see in there, ionized hydrogen.
Mhm.
And so we might end up finding ourselves with a new star system with planets. And over time, that new star system with planets can possibly host life at some point. You know, it's really fascinating. And it starts in the dark.
Love it. Love it. Love it.
Life began in the dark.
Yep. Well, we assume, right? I mean, the Big Bang.
That's
How
right.
do
Well,
we don't know that we could have come from light, right? Who knows?
well,
We don't know.
hot UV ultraviolet light is not friendly to us, right?
Gonna kill this.
You know, this light over here, okay, represents cool red, and this represents hot blue, right? So right above me, I have the extremes of the universe right there. We have the O stars
Cool.
to this side, and we have the red stars to this, to the M stars, which are coolest and reddest, okay, and not hottest and bluest. All right, so I'm feeling getting a tan from this side anyway, you know. And those blue stars give off mostly ultraviolet light, and that makes it really kind of a bad place to go if you think you're going to form life. So those stars, they don't live long enough, for one thing, to foster life. They only live a few million years, okay, and then they litter the cosmos with their guts, and they can possibly start something else down the line, another star system. Betelgeuse is the first star to go in Orion. It used to be an O star. Notice that the stars are changing as we speak. Okay. It used to be an O star, bright and blue. Okay. But then over time, it became a red star, which happened because of the expansion I told you about. However, if you look at the belt stars in Orion, all the belt stars in Orion, they're also O stars. And they are very hot. They will eventually get to the point where they start turning red. Okay. All right. And as they turn red, they're going to end up having a belt of red stars in Orion, possibly. Okay. And then they're going to go supernova like Betelgeuse will. Okay. And Rigel, right? Rigel is this one here. This one. Rigel's this bright, hot blue one. That's going to go supernova as well. And when it goes, it will be red when it finally goes. So that's going to be something to see, because all the stars evolve like that. They start out at their respective colors, but then they all migrate off of that snaky line that we call the main sequence. That's the line in this diagram here, which goes down the middle from upper left here to lower right. Okay, right through the middle, you see that cluster, that little line of stars. Those are all the stars that are fusing hydrogen into helium. Okay, normal hydrogen fusion, right? But they all go this way at some point. Okay, and eventually they will end up exploding. And so Orion, as we see it now, is just temporary. It's actually just a few million years in age, and it's not going to last much longer. So I'll give you an example. When Lucy, little 4-foot Lucy, our hominid ancestor, okay, Australopithecus afarensis, for those of you that like to follow that stuff, okay, when Lucy was running around in Olduvai Gorge in Africa, if Lucy looked up at Orion, she would have seen that star for Betelgeuse. It would have been a bright blue star. She wouldn't have seen that one. She wouldn't have seen a red star. She would have seen the blue star, because Betelgeuse was hot and blue 4.2 million years ago when Lucy roamed the gorge. Okay. Wow. Yeah. So see, the universe changes, although the changes are slow on a human scale, right?
Yeah.
So it's why I made the lights go as it's going today, because it's that slow change, which represents what's going on in our universe. Yeah.
We got a minute and a half till break, Mark.
Yeah, we do.
Mhm.
So I don't know if anyone's got any questions in the chat. I know we've had some, but I saw a few. Okay, so we have, this is Sky to Live fans. This question: can there be dwarf stars that are comfortable or can support a human civilization? Yeah, the red stars. Okay, the red dwarfs may be something that we can live with. Okay, they may be, and the reason is because they are the ones in the universe that have the most planets around them. So those red guys right there, they're the coolest planets. They're the coolest stars. Not very hot, but they have a problem. In their early youth, they're flare stars. They give off lots of flares, lots of flares.
Flashy.
They're very flashy. That's right.
Yeah.
They're flashers.
Yeah.
And with that, we'll be back. When we come back, we're going to go into our UFO discussion. I know we had some questions about that, but this was something that was just on my mind to talk about. All right. But we'll be back right after these words. Remember the stars.
Hey members, the new KGRA DB app is now available on iOS and Android devices. Gain on-demand access to any KGRA DB programming. Download any show directly to your mobile device to listen or watch on the go. Go to the App Store and search KGRA DB.
As UFO reports come in from around the world, the Mutual UFO Network, MUFON, is there. We continue to explore new cases and build our massive database. We share our information with the world in a number of ways. If you'd like to be part of our investigative team, you are always welcome. What could be more exciting than exploring the UFO question firsthand? Join MUFON, find your friends.
You're listening to the KGRA Digital Broadcasting Network. We provide unparalleled coverage of trending news in the world of ufology, cryptozoology, and paranormal phenomenon. Whether you're watching our video live stream or listening to one of our audio programs, you are getting the best from world-renowned researchers and hosts, guiding you through topics the mainstream won't touch. Miss one of your favorite programs? No problem. Head over to the members area at kgradb.com for access to our massive library of award-winning content. Make contact, stay connected, only at kgradb.com.
Welcome back to Sky Tour Radio. I'm Mark D'Antonio. Oh, wait, there's my name right there. And that's Tara Diulis.
Hello.
The only co-host I think that anyone should have on their show. She asks you really cool questions. And you know what? When in previous iterations of Sky Tour Radio, I would ask her to like have some questions ready or whatever. And she started writing like pages of questions. I mean, pages of questions would last like 6 months to answer.
Yeah.
Never mind. I mean, talk about diligence. That's why she's
I have
something.
a curious mind. This is really fun. So
I agree.
interesting.
I agree. I'm very, very pleased to see it. So I just want to mention too. As you know, I'm also MUFON's chief photo and video analyst. Okay, and we have a wonderful photo analysis team. We're currently doing a case right now from San Francisco, and JSCO. See, look, see, she is excellent. You're the one that put that up there, didn't you?
No.
I know. Okay. So, and our photo analysis team, Pat and MUFON, we do a lot of cases, and I'm an astronomer, but I'm also open-minded, and I think it's very important to be open-minded, because if you're not open to the possibilities that the universe is presenting to you, then you'll never ever find them. They won't be there. You'll make up excuses. Now I've had situations and experiences I cannot explain. Okay. And I've had missing time. I had something taken out of my sinus that was put up there after 3 terrifying nights. It was really difficult to deal with. So all these things taken together, you have to say, this means there's something going on. And I think it's very important that we figure it out. And we should be willing to figure it out, and we shouldn't be closed-minded to it. So I'm an open astronomer. I'm not a closed-minded astronomer. We caught, and Tara knows this, we caught on our Sonoran telescope, which is 75 miles west of Phoenix out in the Sonoran Desert. We caught with our all-sky camera. We caught some very interesting anomalies. Some we understood, like we caught a re-entering Chinese rocket that came back in and was breaking up as it entered the atmosphere.
Cool. We
caught the auroras, seen here in Connecticut where I am. They look like this in the sky, actually. They're really pretty. Okay. And along with the auroras, we saw Starlink satellites going over in trains, one after another, and we saw those. In fact, just 2 nights ago, I was reviewing our all-sky camera from the Sonoran, and we caught a Starlink train. And you see these light streaks that come and go like this, one after another. And that's a Starlink train, because each of our exposures is 15 seconds. Okay. So you're watching, and I can set it to anything, but you just watch this 15-second streak, because that's one coming through, then another coming through. And it went on for like 25 of them. Pretty cool. So those are normal things we see, right? And but it's the abnormal things that we see that we can't explain. One such thing that I can't explain is we had an object come in the all-sky camera. It came in like this, and then went boom, and took off in a different direction. And you'll say immediately, well, it's just an aircraft, you dummy. Well, no, it wasn't an aircraft. I analyzed the image, and all it showed was a single light source moving through the sky. So what is that? Is that a rocket changing orientation? I mean, when a rocket's launched, they also leave a launch plume. This left no launch plume. It was just a bright light that came in, went toward the camera, and then it took a turn. Now, it was only about a 30 or 40 degree shift, but it went like this. If you look at it from the top, it went like this and then like that. I've never seen that before. That was weird. The other thing that happened, this was last year, okay, was this was with an old all-sky cam that we had too. I had the telescope, the all-sky camera looked in the sky, and it was looking in one particular direction, and this spider crawled up and happened to get right in the area where the lights of Phoenix, as you can see with these sensitive cameras, you can see the lights of Phoenix 70 miles away, but they're dim. But there was this dim white light, and the spider crawled up and made its profile. It looked like this spider about to eat the entire desert.
Oh my God.
But above that, on the other hand, was some anomaly that showed up that I couldn't understand. Oh, yes, Karen, I can explain that spiral. I do know what it is. Above the spider in the sky was this semicircular light that went like this. Okay, it went like a half circle. I was like, what's that? It was way up high. Okay, it was this big in the sky, literally that big. See how big I made that big?
That's
Tiny,
pretty big.
tiny in the sky. Yeah, it's really big here.
Yeah.
And so then I looked at the next frame, and there was the other half of it. So something way up high went in a very tight, small circle. Something that was not what I would expect to see from a fighter jet, not what I'd ever expect to see from a commercial airliner. And in fact, it couldn't have done that. In fact, I'll tell you why fighter jets couldn't do it either. Because the only light that we would see on a fighter jet is the light from the exhaust, right? They fly around. So as it's flying away from you, you'll see the light coming from its butt, right? You'll see that light. And as it makes the curve, it'll fade away. So half that, if I saw a half a circle, it makes sense. Okay, for half it was turning away and then was done. But the very next frame was the rest of it. And it was exactly the same brightness coming back the other way.
Strange.
Yeah, there's no such exhaust on the front of a jet. So this one was truly anomalous, and I called it as such. So there's a lot of weird things that happen out in the desert, you know. And I mean, I've had my own private flare drop, okay, by jets from Luke Air Force Base. They flew over, and all of a sudden, they leave this string of flares right over. It's like, wow, that's so cool, you know. Don't let them fall into my observatory, you know. But I mean, we've seen a lot of cool things. And people are seeing things today. Now, Karen mentioned this spiral seen over the UK. I know exactly what that is, and the reason I do is because I've seen it before many times, and you're going to see a lot more of them. Okay, I think that the thing that's interesting is if you look in the sky, you'll see more things than you ever thought were there. More satellites, yes, of course. More stars, depending on where you go. More things that seem to move, right? And among them, you might see a rocket launch. And so the rocket launch is something that really shows up as a very interesting anomaly in the sky. Now, years ago, there was one that came out called the Norway Spiral.
Ooh.
And people
Wonder where that was.
I think it might have been in Afghanistan. No.
Okay, that makes sense. Yeah.
The Norway Spiral, people were sending images. I got it literally minutes after people were seeing it. And they were seeing it at 8 o'clock in the morning their time. So I got it early in the morning here. Okay, like 5 or 6 hours earlier. And I looked at it. As I stared at it, here's what you saw. You saw this spiral of material from several sides, all spiraling out from this central hot spot. And then you saw this central hot spot turn black, and this a black circle that got bigger and bigger and bigger and bigger until it was all gone and everything disappeared. Now, people said it's a portal opening up. It's a portal. Oh my gosh, it's a gateway. Okay. And when I looked at that, I realized, no, I know what it is. I really think I know what it is. I believe that this was, a rocket launch gone bad. And I put that out there within hours of this thing, and I actually within maybe 2 hours of this thing happening. While I was supposed to be asleep, okay, I actually was writing this message out and putting it out there publicly. And I came under such fire because they said it wasn't a rocket. No. Okay. And it's like, well, actually, let's just wait it out. You're going to find out that it was a rocket, and that black thing, that black cloud in the middle, all right,
Yeah.
that's where they detonated it, because it was no longer. And when you blow something up in space, you don't get a fireball. It's just the rocket, when they explode a rocket in space and detonate it when it's up in orbit, okay, and it's high in orbit above all the air.
Mm-hmm.
Well, you don't have oxygen to combust and make bright fireballs.
Oh.
So an explosion in space is just an expansion of a lot of debris very quickly. And so you saw this dark circle expanding where this rocket was.
Mm-hmm.
And then, of course, the thing went away. I also said at the time, if you can see that from the side, because it looked like a spiral when you're looking at it, really cool. From the side, it'll look like a corkscrew. Okay. So you got to get some photos from the side so you can see that it's actually a corkscrewing rocket that was out of control. It's called a gimbal failure, where the nozzle wasn't, aligned right, and the rocket was kind of going up like this as going through space, and they finally had to detonate it and destroy it. Well, sure enough, somebody had taken a photo from the side, and it was a corkscrew. And then it was like a few days later that I think it was Russia, I could be wrong, but one of the countries admitted it was a failed ICBM test. Submarine launched ballistic missile, SLBM test. And so you gotta be willing to say the hard thing and say, no, here's what I think it is. And it's okay.
Mark,
No.
I've seen Star Wars. I've seen explosions in space.
Yes.
I've seen fire in space. Are you telling me that's not true? That's
Correct.
Not... Oh,
Mm.
okay.
But Hollywood loves it. Hollywood loves explosions in space.
It's exciting to see them in space, but they last
And-
really briefly,
And you hear them too.
Yes, you do.
Like,
You feel
poof.
it.
Whoa. That X-Wing hit the Death Star. Holy cow.
Oh, interesting.
Yeah.
Okay. Now I'm going to see them differently.
There goes Porkins. God love him. Yeah. But the point being, and Dave Ned says there was a Starlink launch from Edwards. You see them past sunset here in Arizona. Yeah. You see them. When I was just there this past February. I filmed a Starlink, a Falcon 9 launch. Okay. And Mary Ann says, "What the heck is that?" I'm like, "That's a rocket launch." Wow. And she had never seen one. So it was kind of cool. Okay. Mary Ann is our third person in the SkyTour live stream, 501c3. Tara's one of them too. That one over there, that girl. Yeah. And so, that's right. And so it turns out that when we saw this rocket launch, it leaves this plume behind it. And so when you watch a rocket launch, it looks unearthly. I was doing at Contact in the Desert last year, I was doing a sky watch with Ben Hansen, good friend. And as we're doing the sky watch, people were kind of complaining that it was taking a little long to set up. And it was, because we had lots to do, lots to set up. And the buses were late. People were kind of ornery. But while we're standing there, all of a sudden, a Starlink rocket, Falcon 9 launch is going right over our heads. And they watch it go, and they go, "Oh, look at that. It's leaving this plume behind it." And people are just like, now they're in. Now we have them all. And I said, "We ordered this just for you." So now you have it. Yeah. And see, now we have you right where we want you.
Yeah. It's just like a military flyover,
Yes, that's right. That's right. So you see, so there are things that are odd. There are things that look odd, but are normal. Another one is the Starlinks. The Starlink satellites, when they go over, when they first started going over, people saw this tight stream, this tight bead of lights going through the sky. And they're going, "It's an invasion. Ah, we got to get out of here. We got to leave. We got to leave now." They're like, everyone's panicking, like kind of like that War of the Worlds, radio play. But the fact was, Starlink, they launch in a cluster, all right, and they gradually space apart, because each one has a slightly different speed. The one that's first out is moving the fastest. The next one's a little bit slower. So they space themselves out over time, and they take up their new orbital station. And so that process takes several days. So the first day, you got a tight bead moving through the sky. On the next night, you might actually see 25 separate lights moving, maybe this far from each other at arm's length in the sky. And I video captured like a whole series of them, and it was beautiful. It was neat because you see them fade in and then they fade out. Pretty cool.
And we got millions of reports from MUFON for the UFOs in the sky for Starlink. Oh my gosh. Every day. So
yeah.
It was tough because they look like a UFO. It looks like a
they do. They
Mm-hmm.
do,
Yep.
So I want to just throw something up here to kind of give us a little bit of a little primer here to help folks who are thinking maybe that what they're seeing is something in the sky that doesn't make sense. I'm going to show you, first of all, one of the things that I've seen, which is, we have aircraft that we see in the sky, but people are now taking more and more photos of the night sky. And I have received so many of these images. This image you see right here is an image of an aircraft moving through the sky. In fact, when you look at this right here, this is the light trail. You have lights that are constantly on. You have lights that are blinking at the wingtips. And you have lights that are flashing red at the belly of the plane. All right. And that's the belly strobe of the plane, the belly light. And those will, because they're instantaneous lights, they look like little points of light. But the constant on lights, like these guys that I was showing you right here, these guys are actually lights that are going to be on at all times. And so they'll look like just straight streaks, which is kind of cool, So that all said, if we look at the data for this, we can actually discern a few things from this data. We can see the exposure time. This was 6.8 seconds. You can see it right here. All right. 6.8 seconds that it took for this picture to be taken. And you can see also that this particular object, was taken when it was taken. Where it was taken is in the geo location data. All right. And the thing was, this image here, when you see these dots, if you count them, we have 1, 2, 3, 4, 5, 6 white lights that are flashing. So it's 6 flashes. Now, without seeing this 6.8 seconds, we can see, well, that's 6 flashes and a little more on this side, and 6 flashes and a little more on this side. That's almost as long. It's just a little bit less as long than this right here. So we have this little tiny bit here added to this little tiny bit here. And you could figure out that this is about 6.8 seconds. You might come up with 6.5 seconds. But the length of the trail tells you how long this is. Why? Because these flash by FAA mandate at 1 time per second. So 6 flashes, 6 seconds. Now we have 1, 2, 3, 4, 5 red ones. Why don't we see 6 red ones? Well, you'll notice, where the red ones are flashing, they're flashing just before this belly strobe, these strobes, wingtip strobes go off. So flash, strobe, flash, strobe, flash, strobe, flash, strobe. We don't have the flash. And if you look at this one, the strobe, the red strobe would probably, or the red light would probably be right about here on this one. So that 6th one was left out just because of the nature of how long we took this picture.
Hey, Mark, quick question for you, please. How do you know which direction that airplane was traveling?
Well, actually, in this particular case, we don't. And I'll tell you why. Because what we don't see here are the navigational lights. Now, on the wingtips of all these planes, you also have red and green lights. If the light's on the right side, when the plane is in the sky, and the green is on the left, that plane's coming toward you. Think of red right returning. Red right. If it's red on the right, it's coming toward you. Red right returning. And if it's on the left, then it's going away from you. Okay, because green is now on the right instead of the left.
Right.
So it means it's swift. So there's particular directions, but in this particular case, we can't tell, except that I do know. And the reason I know is because I took the picture. Okay, and it was going from right to left, actually.
Okay.
Okay, that's when I started taking the picture, and that just picks up the lights wherever they happen to be in their cycle. Okay, so this is like a typical plane, and it's kind of what we expect, when we look at these, when we look at things like this. So I'm gonna say that perhaps there's enough of these out there, and enough of these kind of photographs that people take, that we should probably be careful about looking at things like that and trying to say that maybe they're, a UFO, because they're not. In this case, we know what is and what isn't. Now, I saw this light pattern in the sky as well. Okay, this is a photo I didn't take, but I did take one just like it, and that's all I saw in the night sky. And they were all moving almost together. The ones at the end here,
Yeah.
those are kind of moving relative to the rest of the pattern. I was like, what is that? At first I thought, are these geese? These look like lights, not reflected light. They look like they're emitting light. All right. And when I examined the photograph further, I found out what it was. And in this particular case, this photo was submitted as a UFO because of the exotic light pattern. However, when I did processing on it, you know what I found? I found this.
Oh.
It's a refueling plane. And this is the aerial refueler. And you'll notice the string of lights on the bottom.
Mm-hmm.
That string of lights on the bottom is meant for this pilot to line up on, so he knows where the boom is, especially at night.
It's important.
It is. Yeah, it's like the meatball, that you hear on. It's like the meatball that they talk about on flight decks of carriers, right? So obviously in night vision, this looks this way, but with a little processing, you see there's more to the story.
Mm-hmm.
So unfortunately,
That's cool. That's a good one.
There's another view taken from another one of the planes that was flying actually with it. I think it was an F-18 Hornet, Super Hornet. And this was taken. And then yet another from inside, looking down at the planes flying in. Yeah, this is
cool.
These are planes flying in. And this is the boom. And this is the operator's position. He lays on his belly to do this.
Oh.
Yeah. There's the plane that took that other picture over there.
Oh, hey, funny.
Yeah. So that's that's kind of neat how that works,
Great perspective.
Oh, yeah. Now, I've also seen things like this, okay? This particular object is what we would say is a contrail, right?
Mm-hmm.
However, when you look at this was part of a video, and the video was moving. This thing was moving up, straight up from the horizon. It's like, whoa, what's that? That's scary, right? You think, well, is that a missile? What is that? Is it some kind of aircraft contrail? Well, the thing is, all right, using some of the Genghis dang refueling planes, I know, right? Using some applications that you have available to you on the iPhone anyway, one called Theodolite, okay, Theodolite, okay, which I use all the time. This was basically, it moved, this was like 4 degrees above the ground, and it went up to an altitude that if you measured, when I measured the top length and the bottom length, or the altitude, it said to me that this was the line of sight was up to 25 degrees actually. And so it told me that this was about a 72-mile long contrail.
Wow.
In this view. Doesn't look 72 miles long.
Mm-mm.
But you're looking at it along the length of it, as it's heading away from you. Okay. And never is that more clear when you look at the distant horizon. You see how it's getting fainter, but you see how the contrail out here is starting to be blown around and widen out, because you see them do that sometimes. But when you get up here, they're a sharp point, because that's where they're just being emitted from the plane. So when I looked at this, I was told, this looks like a missile. This looks like a missile. Well, actually, knowing the time and date, which I was able to figure out, I could find out this was actually a UPS flight that was coming into land in Los Angeles. Yeah.
And it's
So-
not a change in altitude. It's just it looks that way from the picture. I mean, it's
That is
still
correct.
Yeah.
That's a very good point. When you look at this upper one, it looks like it's vertical,
Mhm.
but that's actually, it's moving horizontally right here. It's to the earth. It's moving horizontally to the earth. So you'll say, well, wait, what about this? What about this? Well, Earth is curved. So we're seeing it far away here. We're seeing it far away in the distance. All right. So we're looking around the curve of the Earth at the contrail, much further away
Mhm.
out here. And we're observing from like way back here. So we're looking over the curve of the Earth right here. Now, to people that believe in the flat Earth, leave, because I don't care. You're wrong. All right. I have no problem saying that you're wrong. And so I don't want to hear any of that baloney. But I will say that these contrails sometimes are mistaken for other types of objects. And if you just put a little bit of thought into it, critical thought, you
Mhm.
can figure this stuff out,
Yeah.
you know?
That's a good
So-
one, Mark. Mhm.
Yeah, it is a good one. Yeah, it seems like a good one. Now, this is fun. There are new planes out there that are being used. Exactly right, Carl Becker. That's following the curvature of the Earth, and it's at a level altitude. Thus, the contrails are staying there. They go away under 30,000 feet, roughly. So, new designs are prime targets that people believe are UFOs. And as an example, get ready. Here's one.
Okay, hold on. Oh, what the heck is that?
Okay. This is called a hybrid heavy lift airship.
Okay.
Lockheed Martin came out with it, the P-791. It's very strange looking, and from a distance, you could easily mistake this as something that is otherworldly.
The
And it
side
looks
of
like
the
it
Tic
has
Tac.
looks like it has 4 big sucker feet on it to suck the water out of our oceans or whatever.
Oh, God.
Yeah.
Okay.
It caused quite a stir when it first showed up. And the pads really do look like some giant alien sucker, you know. However, this strange craft can lift 20 tons of cargo.
Wow.
Yeah, you know,
With the
pretty
cargo
strange.
ship?
Yeah, it's a heavy lift vehicle. Now the cargo doesn't go inside this envelope. It would hang underneath.
Oh.
All right. But it's kind of interesting how a heavy lift ship like this could even exist, you know.
It looks
But
like
again,
a
imagine,
dirigible.
yeah, it's a weird one. Look at this.
Mhm.
Imagine seeing that from a distance or
That's a
photographing it.
UFO.
Yeah, it looks like a UFO, doesn't it?
Mhm.
You won't see all these appendages. You won't see the motors from a distance. All you're going to see is the shape and these round little pads and say, what is that? It's a UFO, you know? So I guess, you know, I guess it's pretty crazy.
Does that
Wow.
fly close to the ground?
Yeah, absolutely. It can hit the ground. It lands on the ground.
Well, I mean, it doesn't fly high in altitude, right? When it's
Oh, I see what
flying.
you mean. I see what you mean.
Yeah.
It has to fly high enough to get out of low level winds, so it could fly pretty high, and carry cargo. You know, obviously pretty far. So but it's a hybrid. The motors need to be on for this to fly, because what the hybrid is you have to have some forward motion so that the whole body of this thing can actually lift itself off the ground as a giant lifting body. And that's what we're seeing here. And Daisy and Zoe, this is in fact, a large, weird piggy bank. Ah, you got me.
That's funny.
It does look strange. Yeah. So, but this is the object. Okay. Now we also know about other things. This one's obvious. People know about the Predator drone. There's probably about 100 or more different kinds out there now, and there's going to be a lot more coming up, especially with the small drones that people see. And I know I saw a question about drones earlier, but you know, I have a whole fleet of them actually. I've got not Predators, but I have a whole fleet of drones in my storage area over there. some of them can carry full-size cameras, hundreds of feet into the air and stay up there for 20 minutes at a time. So there's big drones and little drones that people can buy. Big drones and little drones,
I want one that's just right.
Snow White and the Seven Drones, Yeah. Yeah, there is writing on the blimpy thing that you call it. Yeah, and that's Lockheed Martin's P-791 logos and stuff. Okay. Now, one thing I did get, I got a message from someone down in Texas who said, I have a photo that I want to analyze. I do not understand what this is, but it's a light that's going all over the image. And so I saw the image, and it was a blue light that was going ding, 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 all over. And it's like, what's going on there? Huh, that's very interesting. And then I started looking at military drones to see what lights they have. Well, no coincidence that some of them actually have only a blue light.
Blue lights. Mm-hmm.
So I traced the pattern and saw that the separation of the lights based on the FAA 1 second per flash told me that this was at a certain altitude based on 1 second in speed. You could kind of roughly estimate how high and everything. And so adding the Predator drone into the mix, I could tell that it was probably a Predator. And so when I looked into whether there were military bases around, sure enough, there was a drone base right near the sighting. So it turned out this was a Predator being flown at night, probably on some type of maneuver, training mission, whatever. And it was actually a Predator proving ground is what it was. Okay. So we have that happen too,
And those are big, right?
The Predator is pretty big. I have to get the exact size, but they're like small aircraft, So that's really like a small Cessna, right? They're not small. And then, I actually saw one like this that was being transported.
Mm-hmm.
And the thing is, it's being transported at night. Okay.
UFO.
It looks like a UFO. Look at that shape.
You can see it. Mm-hmm.
Yeah, it looks like a disc.
Mm-hmm.
Okay. But this part here bothered me. Okay. I didn't know what that vertical thing was because it looked like I see wheels here. So I was just trying to figure out what that might have been. And so for all the world, it does look like a flying saucer for all the world.
It really does.
It really does. It's like, we finally got one.
And doing it at night.
Yeah.
Suspicious.
But the thing that bothered me was this bulge here was off center. It's and this right here, this was a sharp edge point. This was a sharp edge point. So what's going on there? I couldn't figure that out. So I started digging through like Flight of the Navigator, Michael. Yeah. I couldn't figure out what this was initially because I didn't know, but I had a feeling that it was a well-known object that was being done, transported. And I figured that it was probably this guy right here, the RQ-170 Sentinel. And the RQ-170 Sentinel, if you take this thing off the front, there's that sharp edge. That's the landing gear. And these wingtips actually can come off. And this is assembled on site. See? So this is assembled. It's not always like that. They put it together. So it comes apart there at the root. And so you just see this off-center bulge. You see that and that. Now, I don't know about the wingtips in the back, but I felt this was an RQ-170 Sentinel that was being transported. Now, there's another kind out there that is possible, and that was this one, the X-47B. It's a Northrop Grumman. Okay. If you look at this one matches better what we see. If you take these wingtips off here and here, right?
Mm-hmm.
And you put that on a large trailer truck, this is what you would see.
Looks
this
more
is what you'd
disc shape.
see. Mm-hmm. It is more disc shape and that profile. So when I saw this one, I said, I'm changing my mind. It's not the Sentinel. The Sentinel has those rear rudders, and those are probably fixed and don't come off. This one doesn't have them. All right. But it has these wingtip extensions, which I think either fold up over the top or they come right off, you know. And as Daisy and Zoe Amethyst, our faithful SkyTour live stream listeners and viewers say, this is exactly that. Okay. So I'm pretty sure that when we look at this stuff, we can expect to see more of these transports going on. If you just cut it right here, cut it right there, and take this part, well, that's what we're seeing here. Looks like the X-47B.
Yeah.
Okay.
Wow.
The wheels are even in the right place. Okay. And he's covering his face. I think it's kind of funny. No, he's not. I'm just kidding. Right. So that's the X-47B. Yeah. And so now, of course, we have drones. All right. I show this one. I'm kind of enamored by this one. This one's hanging in my shop. This is the first drone ever in the state of Connecticut.
Ever.
Yeah. We built the first drone in Connecticut ever.
Wow. We
got a metal shop to actually fabricate an aluminum frame for us, and they actually did a really nice job of making this. This nose cone I have here, okay, that's actually a clear cover nose cone, which was part of a Virginia class submarine that I made for the Navy.
It's like Robbie the Robot,
right? And I thought that looked cool, so I stuck it on the top. Yeah. And so this is hanging from the ceiling in my workshop. You know,
neat.
So yeah, this was the first one, and I had a Lawrence Livermore scientist here for 13 days, and we're building it and trying to test it. And for a while, it was a buzzsaw tumbleweed on the front lawn. Okay, it was like, and we had to work out the PID loops, I should say, for those who understand them. But I had to work out some of the programming to make sure that it would fly. But obviously, drones have come a long way, you know, really cool. But this was designed from scratch here, and doesn't look bad for considering that we had a lot of people follow what we did, obviously. Like here's another one we did. Okay, this was used for a National Geographic production. We created it in 2 days, and this was a UFO that we created, and the idea was to send this up into the sky during a snowstorm with bright blue lights that you can see reflecting on the ground here, and with these bright, brilliant white lights, and it looked like a blue haloed ring of light in the sky, and people had no idea what it was, and we flew it over a busy shopping mall. And when we landed it, we brought it down and landed it right in the middle of the shopping mall so people could see it. So the idea was, we created this event to show people specifically how off-the-shelf components could fool you. All right. And it was basically to show people how technology could go faster than their understanding of objects. And so that's what it was. Now we exposed the entire thing, showed how we built it. The whole special was about, how we built it here in the shop. And it was kind of cool.
And you started with a hula hoop.
No, actually, that was actually... These things are actually interesting. These are long straight tubes that I folded into 4 segments, and they're used to run control rods for radio controlled aircraft.
Oh, well, that's convenient then.
Yeah, and I bent them into a hoop. That hoop was hanging in my shop for years until finally I wanted the lights for another project. And that's what happens, with movie props and other things like that.
And artwork.
Yeah, once they outlive the usefulness, you say, hey, I want this for something else. And so you get rid of that thing, Yeah. A little aside, okay, and before we get to this, let me just say this. A little aside. I was working in London on special effects for a submarine show on A&E or something like that.
Cool.
Or maybe Learning Channel, I can't remember. And I was building these special submarine models that would operate underwater. And I was working in the BBC Central, which was at North Acton, London, and I was in the special effects shop for the BBC. Everything around me that I was looking at was all stuff that I knew. Okay, there was a room full of Daleks from Doctor Who, the robotic Daleks,
fun.
and the TARDISes, the many different flavors of the TARDIS over the years. And as I walked onto the floor, there was this large plywood piece laying on the floor that was loose, and it was blocking a hole in the floor because this was the second floor I was on. And the guy said, "Be careful on that. That's you don't want to step on that, Mark. It's you can fall through to the downstairs. It's not good." "Oh, why? What is it?" He goes, "Well, we had to cover. It's a hole in the floor. We just cannibalized one of the TARDISes, and we took one of the sides and put it there." I was like, you took a Doctor Who TARDIS and ripped it apart to make it a walkway?" "Yes." Couldn't believe it. People listening
How
will know what
cool to be around all that stuff.
Yeah, and I'm opening a double panel cabinet to get some paintbrushes or something to paint one of the models I was working on, and a model fell out of my hand and landed in my hand. I had it in my hand. It was the Red Dwarf from the British show series Red Dwarf. The Red Dwarf itself was in my hands. If I had a pocket big enough. And I turned to the guy and I said, "This is the Red Dwarf?" He goes, "Oh yeah, that piece of junk. Yeah, we got to go through that and rip and throw all that stuff away." I was like, "Can I have this?" He goes, No, put it back. He's just gonna toss it." I'm like, "Okay." And I put it back. I'm like, maybe I can break a piece off, I didn't. But so in other words, that's kind of interesting how that stuff goes. That's a little aside. Sorry about that. But it's interesting. And then this guy was another one that had a very swept wing. This one had a name. I know because I worked on this. This guy right here was called a MPUAV. And Karen, Red Dwarf was great. This was called MPUAV. We called it the Birdie when we were working on it.
Looks like a folded piece of paper.
It does look like a paper airplane, doesn't it?
Mm-hmm.
What you don't know is from the front, it looks like a malevolent flying shark. Okay. This is an open inlet for the exhaust, for the air to go into this high powered jet engine back here.
Wow.
And there's two of them. And we built this. Now, what happens is these wings fold up and they fold right up tight around it, like me hugging myself here. Okay. And then they open up when it gets to the surface. And what happens is this thing launches like you see it here, but it launches out of a missile tube of a submarine. And it's folded up and it comes vertically to the surface, flips over, unfolds its wings, fires its rocket engines, and takes off and flies around, does a photo reconnaissance mission, comes back, lands in the water, folds up its arms, folds up its wings, sinks back down, and navigates back into the missile tube and goes home.
What?
That's right.
How big is that thing?
Well, if you look at the size of the person right here,
so it's
actually it's once it's folded up, it's the size of a missile tube. Wow. In diameter. Now, the thing that's interesting about this is that this particular object was flying over Lake Pend Oreille in Bayview, Idaho, and it was being tested. And there was one particular guy saw it from the resort at the other end of Lake Pend Oreille, which you see here in this photo. Okay. Mm-hmm. And it's a lake that's over 30 something miles long. It's a big lake. It's also known as the deepest lake in the United States. And this lake, it does fly, Isabella. This actually flew very well, actually. And this object, this thing was seen flying, and someone took out a camera and took a picture of it. And naturally, guess what they did? They submitted it as a UFO. And who got it? Me. Now, I was at a crossroads because I have to keep the secrecy of this thing. At the time, it was secret. Yet, I also wanted to give them answers because I knew what it was. the photo they submitted was of this thing right here. Okay.
Mhm.
And so this guy ended up flying several times, and the guy that took the picture was probably going to come back with many of his friends the next day. So I was working fast. I called the program office down in Washington, and I said, listen, guys, someone's photographing the birdie at Pend Oreille, Lake Pend Oreille, and they're submitting it as a UFO. On the other end of the phone, I got, hey, that's great. No, that's not great. Okay, because he's probably going to go back and bring 10 of his friends tomorrow, and they're going to photograph the birdie flying again when you're doing your flight test. And now I'm hearing silence. It's like, total quiet. And I said, so unless you want them to photograph the birdie doing something you don't want them to see, you might want to come out and say it's one of ours that's being tested. And if you do that, I promise you, from my experience, they'll all go home. Disappointed, but they'll go home. And that's exactly what happened. He finally said, all right, well, I'll send you a statement. He sent me the statement that day. I distributed it to the guy that sent me the report, and to MUFON at the time, and they all went home. So this is an example. The actual it says figure that ring is 3. Oh, you're trying to estimate the diameter. No, you can't estimate the pad eyes. Those are oversized specifically to this vehicle. This particular thing fits in a missile tube of a submarine. I'll say that much. All right. Once the wings are folded. So that said, you can find it if you want to know about this, actually, because they say it's canceled. It's a canceled project. Now it's known by another name, not MPUAV. It's known as its official name, Project Cormorant, like the bird.
Cormorant, okay.
Cormorant, Cormorant. Yep. So look up Project Cormorant. You'll find it on Wikipedia. You might find some of these pictures. Okay, I don't know. But this project was canceled. Now, what a canceled project means in the military, because I've worked for the Navy for decades doing this stuff. What a canceled project means is that somebody else is paying for it. Okay, that's all it means. Private? It means no, not necessarily. Another agency was probably took up the charge and started paying for it. And that's the kind of thing that happens all the time. They say this project was canceled. Well, this agency is not lying. They canceled the project. They're right. They did. But another agency took it on. And that part they don't say. So, you got that. So it's a very ominous looking thing when hauled out of the water. Okay. Now, it's not the only thing. Now we go from water to outer space again. One of the things that we have that's the bane of our existence as photo and video analysts are lens flares. And you can see in this particular photo from Apollo, you see this bright light here. And people have said, that's actually a UFO. That's a UFO. Yeah. Or that's the studio light because Kubrick was doing this. Okay. Oh, yeah.
Someone opened the door to the bathroom and the light was on.
Yeah, yeah. In some of our live streams, I show people that not only is that not true, I show them the equipment still on the moon using the Lunar Reconnaissance Orbiter quick map.
That's so cool too.
You can see all that stuff.
Yep.
You can see the rover here for this Apollo mission on Apollo 16. You can see the rover still sitting on the moon where they left it while they walked back to the lunar module and took off. Okay. And while it's left is the square descent stage, which you can see, it's a lot of, I think they did get Kubrick to do it, but to do for the most realism, he suggested they do it on site. And so they did.
That's funny.
On the moon. Yeah. So this is a bane of our existence, these lens flares. And so when you look at these things, in the glow of the sun here, just out of frame, the sun is very bright. The moon is very dark. The moon is actually quite dark. And it's actually a gray that's like an 80% gray, 88% gray 88% reflectivity actually. And so when you looking for stars in the sky, even if you turn away, you don't see them because you're shooting for the moon, and as dim as the moon is, it's way brighter than the stars. So to expose the moon properly and get the detail inside of a dark wall of a crater, you have to drop your f-stop and take a shorter exposure, which means you're not going to get the stars. So black stars in the sky, you're never going to see them. The astronauts saw them when they took their gold visor up, which he's got on now right here. The gold visor protects him from the ultraviolet rays of the sun because there's no protection for that up there. Okay. And when you actually pick that up and look in the shaded region of your suit and up into the sky, you can see brilliant stars. Okay. Because they're there, but you can't see them with the cameras because the cameras were tuned to photograph the moon, not the sky.
Right.
So really interesting stuff. Okay, lens flares also exist in other ways. This is the famous Altoona lights. Okay, this one was submitted as a trio of UFOs coming into Altoona, Pennsylvania. And I looked at it and said, well, it's a time exposure. Okay, we can tell, first of all, by the dragged out lines that are supposed to be points of stars and by the vastly overexposed lights here. Yeah. Okay, these vastly overexposed lights, in my experience as an astronomer and photographer, will cause artifacts on your image, and not only primary ones, but secondary and tertiary ones. For instance, this is the primary brightness. Here is a secondary artifact called a lens flare, and then you have another one down here, another set. See, right? And they're going down closer. And if you draw a line through that top part right there and go down straight through, it'll take you right to the light source, which is lost in the oversaturated image. So there's like 3 or 4 light sources with 2 main light sources. And by the way, these 2 are kind of a yellowish orange, which are known in our terms as sodium vapor lamps. They're the reddish lights that you used to see on highways all the time. Yeah. So lens flares are problematic and cause issues for a lot of people. All right. Now, here's one I'll show you real quick. Here's an image of the moon overexposed. And here is something submitted to us. Okay. So I said, well, wait a minute. That looks like a lens flare. And the actual size of the moon is this little thing right here, which is true, what it was. Now, how do we know? Because this actually is my test photo I did. The photo was very much like this one that was sent in. But I went out and I did test photos. And here was one. Here's another. Here's another. Okay. And if you draw a line through all these things to the reflections that you see, okay, where they all intersect should be the center of the frame, because lens flares are symmetrically on the exact opposite side as the bright spot. And that's exactly what we're seeing here. This right here turned out to be the exact center of the camera frame. And that is a giveaway for a lens flare if you have that. So you take more than one picture, and this is what you get. So lots of interesting stuff here, and it's all very important. Now, we got one that was a boomerang UFO. Okay. This was a boomerang UFO in Burbank.
That's cool.
This was a while ago, yeah. But you'll notice this boomerang UFO, it's like, wow, that's pretty cool. Except when you get to this one down here. Okay, this one right here, that's a little odd because this one doesn't seem to fit the rest. It seems like it's got some kind of wrinkle in it or something. As it turns out, this was something else. As it turned out, this was one of these, a solar balloon that had actually folded in half because it wasn't quite hot enough to maintain the altitude. It was probably clear, one of the clear ones. So it wasn't black like this one. These are solar balloons. These are fun. You just let them fill with ordinary air and then let the hot air inside get heated up. And so it rises through the cooler air, just like the Montgolfier brothers discovered when they created the hot air balloon.
That's amazing. Yeah.
Yeah. So boomerang UFOs, fun stuff, you know.
Cool.
And you launch it on a day that isn't too warm. And when you do, then the inside of the balloon can get a lot hotter than the outside of air, and so you'll get a much more pronounced effect, and the balloon will remain more rigid. If you launch it on a day where it's not quite the right day, then you get the bending and you get the boomerang effect, and it's going to bend at the spot that is the sympathetic bending point for a balloon under force from, say, winds, and that's the midpoint, and that's just what we see. You know,
That's a
actually
good one.
Yeah, I know, that's a cool one, right?
Yeah. Hey,
So,
Mark, we've got about a minute and a half to go.
I know we do. We only have like
Wow.
a couple minutes left. So what I'll do is let's just talk about the rest of what we saw. So first of all, I'm going to tell you right now, I do believe that UFOs are out there. I believe they're here. I believe that alien civilization has made it to our planet. It's not a nutcase type thing. It's everybody watching this probably also believes this. But what I like to do is to give you reasons why this is true, and reasons that will give you an argument when people talk to you about things that are not possible. Like, we have people that are closed-minded and they'll just say, that ain't true. There's no UFOs. There's no aliens. And it's like, well, I will tell you this. All right. I'm pretty sure that based on my other talk I do, which is the one popular about the gravitons, and which Avi Loeb now, even from Harvard, also now agrees with, and I've worked with Avi a few times. Okay. I think that they do travel interdimensionally in that fifth dimension outside our 4 X, Y, and Z move through time, which is everything we know. Okay. And everything we can see. Right. And that fifth dimension is where it's at. Right. So that's how they can go long distances and not even take a long time to get there. That's how they can travel at right angles in the sky and not feel any force. And thank you, Kevin. And that's how they can actually travel long distances and not actually hit anything, because they're not moving through space. They're moving out of space and then punching into a new spot in space. It's a punch out, punch in mechanism. Yeah. So anyway, that's where it goes.
Okay, good.
If your head blows up, well, good. We did it.
Yeah. Well,
Tara,
something I would love to hear more about, Mark, honestly, about going into different dimensions. So yes.
I can do that. I can do that talk if you want. We can talk about that. But folks, you've done it again. You've wasted another 2 hours with us. Yep. If it's clear, we're going to stream right after this at 10:45 p.m. from the Benson telescope and the Sonoran telescopes, if they're clear out there. So watch for a Facebook announcement. Also, that will be at 10:45 p.m. tonight, and that's at SkyTour live stream or youtube.com/@STLS. Well, we'll see you then, and thank you for joining us tonight. It's been fun.
Thanks, everyone. Thanks, Mark.
There go our stars.